Hey there, math fans. You might be wondering why we're doing all this solving using logarithms. Like, what is this going to be good for? So I need to give you some really good applications, and I think you'll like these. They're about money, and so yeah, everybody deals with money at some point. So anyway, the essential question is, how can I use my newly acquired logarithmic knowledge to help me solve real-world problems? So let's get right into it. First of all, the number one place where you will see exponential growth in your life is with compound interest. What compound interest means is that you put money somewhere, and then your money gets returned higher, and that's called with interest. So you give your money to someone, and then because you're letting them use your money, they will give you more money back, and this is what interest is. Maybe I'll talk about it a little more in depth. But what you need to know is that this is a way that you can make money without actually doing anything. You just put your money in, and then you get more money back. Banks do this for you, and so forth. Like the compound interest is in relation to this formula. I just need to explain what the variables are. So first of all, P. This is the principal, and I'm pretty sure you spell it this way. It could be the LE way, but anyway, the principal is the stuff you put in at the beginning. So it's the money you invest at the beginning. This is kind of like the initial amount of money that you put in, the money you invest or the initial amount. A is the amount of money you have, like later, like the amount of money you get back. Or I'll say the amount of money at time t. So you're putting a certain amount in, that's the principal, and then a couple years go by and you get money out, that's the A. The R is easy, the R is rate. Like, what is your interest rate? Is it 5%? Something like that. T is also easy, this is time. And sorry, the screen's getting a little crowded, but yep, you can sort it out. And then finally, we have this N. This is the most difficult thing to understand. This is how many times the interest is compounded for per year. So I'll just say how many times per year. As it turns out, you can earn interest at different times. So sometimes you earn interest just once per year, so n would equal 1. Sometimes you'll see something like it's compounded quarterly, which means they're going to give you interest 4 times in the year. Or you might see something like monthly, which means they're going to give you the interest 12 times in the year. So it's just how many times they're actually giving you the interest. Okay, let's do some problems. I'll try to keep them short. These problems are nice. They're plug and chug, which means, yeah, just plug them into your calculator. So this one. Your bank is really good to you. They give you 2% interest compounded quarterly. This is insane. I think my bank gives me like 0.1% interest or something like that. This is a very, very, very nice bank. You put $1,000 into the account and you just leave it there. How much are you going to have after 4 years? Okay, so we need to plug into this formula. We have A equals P times 1 plus R over N to the power of NT. Okay, so let's start filling some things in. First of all, obviously, what is my time? It's 4 years. Okay, so let's make this 4. Next, let's deal with the N. The interest is compounded quarterly. So that means 4 times per year. That means my N is going to equal 4. So my T is 4, my N also happens to equal 4. So let's plug those in. Next, the rate. Here's my interest rate. Now, you can't just put 2 into the formula. Remember, when we put percents in, 2% goes into our math equations as 0.02. Why? Because we moved the decimal 2 places. It's like dividing by 100, okay? So 2%, 0.02 is what I should be plugging in, 0.02. Finally, this money, the question is it the A or is it the P? Well, this 1,000 is actually the P. Why? Because remember, the P, the principal, is the amount of money you put in at the beginning. The A represents how much you will have after the amount of time. Notice, all of my knowns are on one side of the equation. So all I have to do is plug this straight into my calculator. It will give me A. So let me pause the video. I'll plug it into my calculator and then, yeah, I'll just give you the answer. Yeah, okay, so like I just put this whole thing in literally just in one step, and it gave me that A, the money I have now, is $1,083.07. And that's really nice. Like, thank you, bank. Like, I gave you my $1,000, you used it to make more money, and then you gave me back more money as a result. Sweet. I earned $83 just for nothing. The bank just gave me interest. I think I just have one more example. Yeah, one more example. Okay, so same bank. This time you put $1,000 into the account, but instead of giving me a certain amount of time, notice that now they're saying how long will it take for your account to double in value. Okay, so let's see what's the same and let's see what's different. I have the same formula. I kept the situation pretty similar so that we don't have to talk about it too much. I'm still compounding quarterly, so n is 4. My interest rate is still 2%, so that r is 0.02. Whoops. I'm still putting $1,000 in, so this is P, but now they're asking how long. So since they're asking how long, this T is actually going to be my variable, okay? So what is A? Well, they're asking me how long is it going to take for the account to double in value. So if I put in $1,000, how long will it take to double? What's my A? What's double the principal? Well, that's 2,000, right? Okay, now here's the issue. The variable is in the exponent. What do I do? Well, we know what to do. We need to use logarithms. Now, remember, I said that if the variable was in the exponent, there are kind of two different ways we can deal about it. There was technique 1, where I kind of said, are both sides of the equations looking similar? There was technique 2, where I had to make the translation. So let's look at this. This side has a variable in an exponent. This side, it's just 2,000. So this is going to have to be technique 2. I'm going to need to make the translation somewhere, the logarithmic translation, using the definition of the logarithm to get the t out of the exponent. Let's simplify some things first. First of all, 1 plus 0.02 divided by 4. Let's simplify that. You can do this in your calculator. It's going to end up being 1.005. Okay, to the power of 4t, 1,000, 2,000. Okay, sweet. At this point, I don't yet have my power isolated. I should divide both sides by 1,000. And that gives me 2 equals 1.005 to the power of 4t. I'll keep this in parentheses. Notice, double, I ended up with a 2. That should happen, just so you know. I'm on the right track. At this point, I have the power isolated, and so I'm going to make the logarithmic translation. If you don't remember what this is, go back and maybe watch the other 7.6 video. The point is, this is going to translate to log base 1.005 of 2 equals 4t. And at this point, I'm good to go. I can use the change of base formula to figure out what this is, or you know you've figured out by now your calculator has this button. And then all I need to do is divide by 4 to figure out t. So again, let me just calculate this super quick. I'm using the change of base formula because I don't mess around with that other key. Change of base formula is so easy to do. I'm also dividing by 4, and I get that t equals 34.744 years. Nice. Now, really, my interest is only being given to me every 4 years, so this might be a little illogical. Maybe I should really say that t equals 35 years, like round up to the next kind of like payment period. Or maybe if we're being really technical, since it's compounded quarterly, maybe 34.75 years would make sense. But anyway, the point is, around this many years is when I will have doubled in value. And that's really not very long, even at a decently low interest rate. So compound interest is very, very good. That's why you want to start investing early so that you can retire with lots and lots of extra money. Anyway, summary, if the variable is in the exponent, make the translation. You know this by now. Have a nice day.